Assalamu alaikum. I welcome all of you to the class on reactive intermediate. As we were studying the reactions of carbenes, that how carbenes reacts, and after that we came to know that the alkyl carbenes are very much unstable, or in the other sense they are very much reactive. They decompose or they react intramolecularly. I mean to say that the alkenes, they react with themselves before they react with the substrate available, the other substrate or the reagent or the reactant available to them. As soon as those alkyl carbenes they are produced, they react with within itself or intramolecularly. So that's also called as intramolecular reaction of carbenes or decomposition of carbenes. So today our main topic is insertion reactions of carbenes, but let's briefly finish the decomposition of alkyl carbenes first. So these are some substrate. This is substrate A and this is substrate B. We have studied this reaction numerous times, that when these azides they are exposed to the light or heat, they produce the carbenes. So the carbene as it is produced is in a singlet state, and if the carbene has its ground state triplet one, just like those carbenes, the alkyl carbenes, they have their ground state as a triplet state. So they either inter-system convert from singlet to the triplet state, or let me add something else, that singlet carbenes are very much reactive, so they react with itself. It is the singlet carbenes which makes the alkyl carbenes to decompose or to do some intramolecular reaction. These are two substrates. This is substrate A and this is substrate B. They were exposed to the light and they produced two carbenes. Now there is another thing which we need to look at. Here on this alpha carbon and this alpha carbon, this is an alpha carbon or L-alpha carbon or a carbon adjacent to the carbene. Both of these carbons, they have hydrogens present on it, but I have just written one hydrogen here. There are two more for simplicity, and here I have written the two hydrogens. Okay, so now as we have studied that these carbenes, they decomposes or they do some intramolecular reaction. So the hydrogen, it is quite clear that the hydrogen should move along with its electrons to the carbene's carbon, and it should sit on the carbene carbon. So that hydrogen which moves along with its electrons, bonding electrons, or hydrogen H negative, when it is moving, it is called as the hydride. So a hydride should shift just because of the carbene. Carbenes are very much electrophilic, as we discussed previously. So which hydrogen you think will shift? This hydrogen, the hydrogen HA or hydrogen HB. So the product, so there are chances that both of them are well capable to move along with their electron, because both of them are sp squared CH bonds. Okay, this is CH, and the hybridization of the carbon is sp cubed, sorry, not sp squared. This is again sp cubed or sp3. So either this will move and a double bond will be produced here, or this will move or double bond will be produced here. So both there is a chance that either should move. If this A moves, it will give this product, because a bond will be produced here. How it will be produced, I have explained it many times, but let's see. These will come and sit on this carbon. Okay, so this will be produced, and it can also produce another product where the hydrogen, this hydrogen or this hydrogen should move to this carbon along with its electrons, and a double bond is produced here. So this is where the hydrogen A shifts, A hydrogen A shift as a hydride, and here hydrogen B shifts. It's not a real shift, as the reaction is concerted. Both the things happen at the same time. The movement of the hydrogen and the electrons of the carbenes, they move in a cyclic way. So it is a concerted reaction. But when the product, but experimentally, the product B was more. This was produced much more in amount. Reasons being that the more substituted alkene is more stable. Actually, in reality, it is not the case that it's just because of alkene that it is stable. It is, the main reason is that when this carbene shifts, when this proton shifts and form a double bond here, so the angle of this carbon, it changes from 109 degree as is the requirement for sp cubed carbon, to this is sp cubed carbon. So as you know that any substituent attached to the sp cubed carbon, it has 109 angle with each other. Or let's see, methane, each CH have 109 angles, 109.5 degree angle with each other. Okay, so it produces a tetrahedral shape. But now when a double bond is produced, so the angle changes to 120 degrees. So it's actually the the removal of the strain or the release of the strain which makes this product. So, but for simplicity, we can say that, and it's while very easy to understand or to comprehend things, that the most substituted alkene is produced. What about here? Again, here this carbon, this hydrogen can move, or this hydrogen can move. But there is one thing: the actual product which was observed experimentally was produced just because of the movement of this hydrogen, by the shifting of this hydrogen. So a double bond was produced here. These lines are methyls. Okay, CH3, CH3, CH3. These are CH3s, and this is hydrogen. For inorganic chemistry, these lines, they mean simple CH3s. Okay, and this is very simple. You may know that this is ethyl group, CH2, CH3 group. So it is produced exclusively, or the major product in this reaction. The other product is a minor product. So again, a most substituted double bond is produced. Let me write another substrate. Okay, now what will happen? Again, there are two chances that either this hydrogen can come here and a double bond is produced here, or this hydrogen may be shifted. The hydrogen, I'll write it as hydrogen A or hydrogen B, so we should name it. But when the product was observed, it was exclusively, or the major product was this. And the HB remained there. doesn't migrate. So the alkene was decomposed in this fashion. So there are two things. One thing is that if that hydrogen was supposed to move, it would have produced a product like this, which was produced in very, very less amount. Okay? This. Again, let's name this product as 1 or 2. This product and 2. This product 1 was formed as a major product, and this product was formed as a minor product. Okay, so we can again say, just like we were saying that tertiary or the most substituted alkenes double bond, the most substituted double bond is more stable, so it was formed. Again, we can have that analogy here. We can say, oh, this oxygen, this structure and this structure have something. The structure 1 has the lone pair of oxygen, and it is adjacent to the alkene double bond, so it can do resonance. It can do resonance like this. Okay, that will stabilize. That will stabilize this molecule. Now, as you know, there is hydrogen present. Don't mistake it for carbene. It is a negatively charged carbene ion. This has, and here this lone pair cannot reach to the double bond in order to produce another canonical form of resonance structure. So they say that this structure is stabilized. Yes, of course, this structure is more stable than this one. We will discuss it later, that stability to what. But right now we can say that, oh, this is this structure has oxygen, and it is in resonance with the pi bond. And so it stabilized the structure. So this is more stable structure because it can produce resonance forms, and this one is not that much stable because it doesn't produce resonance form like this, because oxygen is not in resonance or in conjugation, in conjugation with the double bond. Here the lone pair is in conjugation with the double bond, but it's not the basic evidence. Okay, the product is more stable. So what? The product is produced after the reaction is done. It is just like that we say suppose it's just like that we say to someone that you are very lucky guy. He say, how? That your grandson will be a king, and you will be living then, and he will be giving you very much big treasure or something, money or etc. Man, we need to focus on the present. We should not go in the future. That we may be thinking, okay, this is the product. This product is formed because this product is stable. Okay, this has. This sentence or this statement plays its role. It's okay, but first the reaction is done, then the product is formed. Then how does this reactant know that this product should be formed or this product should be formed? It doesn't know that this product that his let's see, it is a father and it is the son. It doesn't know that my son will be very much stable or strong, so I should produce that one. Okay, not this one. The actual reason is not here. The immediate reason is we should discuss the present, not the future. We should not go to the product. Yes, thermodynamically the product is stable. It makes sense and it's very okay argument. But right now, why the substrate does this thing? Actually, these lone pair has to play a role. Okay, oxygen has a lone pair, and it can push this double bond and can weaken this bond. In the transition state, these lone pairs are helping to push this hydrogen toward this carbene. Okay, the main reason is with the substrate. We should discuss the substrate, not we should discuss the substrate or the father, not the son. That after 20 years his son will be born in 1 year, after 1 year, and after 20 years he will become a king. Okay, that's okay, but right now, so what is happening? So this is happening. This thing is, we need to study this thing. So that's why this product is produced exclusively or as a major product. What about this product? Again, I say that, oh, we have a more substituted double bond is produced. Wow, this is and the other will be very less substituted double bond. Okay, we can say this argument. But this is not the case, and no one is going, believe me, to buy it. The reality is, here big strand is released. Each hydrogen wants to release the tension on the strand in the substrate, and in this case, the oxygen can push this thing, and hydrogen can move here, and it can produce the double bond. So this is the case where this thing is so this is the case that how this reaction occurs. Okay, so we must look to the stability of the product, but along with that we also need to focus on the substrate, because anything which is happening is happening in the present. Right now, what is happening? You should not go and discuss the future. That the product is stable, so the reactant, it's very wise. It's thinking of the future that I should give or produce this product. And this reagent, again, wow, it is again very intelligent. It thinks that I should produce this one because it's more substituted. No, it might be some argument, but it's not a full part of the story. It may be one aspect, but not the full aspect. So the main thing is why this moves and why this don't move. The only thing is the relief of a strand. Okay, here why this moves, because both are secondary. This is the secondary carbon, this is a secondary carbon. It is adjacent to a living group, adjacent to a heteroatom or oxygen. So we can put forward another argument which may be against it, but it's not the scope of the case, the study right now. But right now we should say that these are the products. So now we have to study the insertion reaction of carbenes, that how they insert.